Hey guys, welcome back. So in this video we'll be looking at confusion matrix. We'll take the example of binary classification and I will try to make this concept of confusion matrix more generalized, and I'll talk a little bit about multi-class classification and how can we find the confusion matrix in that scenario. Okay, so usually whenever we have a model and we get the results, we actually write those results as predicted values. Okay, and we try to compare those predicted values with the actual values of the data set, and then we try to find out the accuracy, recall, and precision of that particular results. Okay, so let's suppose that we have a data set and we got a table something like this. So there these are not true and false. We'll separately write them in terms of yes and no. So in place of true we are just writing yes, in place of false we are writing no. Okay, so this will be no, this will be yes, this will be no, this will be yes. Okay, so we have some problem of binary classification where we are classifying a particular record in two categories that are yes and no. Okay, and after testing the model, we got the results as predicted values, and we have the actual results in against those predicted values, right? And so how will we make the confusion matrix? So here you can see I have already created a confusion matrix and I have taken an example. So what we'll do, we'll create a matrix where one side there will be actual values, another side there will be predicted values. So this is actual no, this is actual yes, this is actual this is predicted no, and this is predicted yes. So we will be writing the entries where entries as predicted no. Okay, so this 50 represents the number of records that were actually no but predicted as no. Okay, and here 10 specifies the number of records that were actually no and they were predicted as yes. Okay, so we got 50 such records that were actually predicted as no, and in actual their label was no, and we have 10 such records where the predicted value was yes and the actual value was no. Okay, and similarly here we have 5 records that were actually predicted by our model as no, but the actual label that the records had was 5 was a yes. Okay, and here you can see we have 100 entries where the predicted value was yes and the actual label was also yes. Okay, so in this way we kind of created a contingency table with these rows and these columns. Okay, so I hope you are getting a bit of understanding via this matrix here. Now you must be thinking how to get the recall and accuracy and error and precision out of this matrix. It is very simple. You just need to see what are the true positive, true negative, and false positive and false negative. Okay, so remember that this here no, you can see that no has been classified as no. Okay, so whatever the entries, whatever the records were actually no, they were classified as no. Okay, so let me change the color pen. So this block here will represent the true negative. Okay, it is true negative. Okay, let me take a brighter pen so that you can just have a better vision here. Okay, so this block here is true negative, and similarly you can see that actual label was no and the predicted label was yes. Okay, so this is a false positive. Okay, false positive, because this label has been predicted yes in a positive manner, like this has been a positive response, this is yes. Okay, but the actual the actual label of these records were false, were no. Okay, but still our model has given the output as yes, so this is false positive. Okay, similarly you can see that here our predicted value was no and the actual value was yes, so this is false negative. Okay, this is false negative, this block here, this cell here is false negative. Similarly here you can see that the actual value was basically yes and our predicted value was also yes, so here you can see it is true positive. Okay, so you can see that uh, in this way we can just get these true positive, true negative, and false positive and false negative. Okay, now you need to remember these formulas. So whenever we talk about recall, recall is nothing but true positive divided by actual yes. Okay, so how many actual yes are there? You can see that actual yes is given by this row here. Okay, so you need to take the sum of all the entries that are here, and I have already written the sum, it is 105. Okay, so and the true positive, we can see that true positive is already 100. Okay, so recall will be 100 divided by 105. Okay, it will be something near about 0.95, I guess. Okay, similarly if you want to calculate the precision, precision will be nothing but it will be true positive divided by predicted yes. Okay, predicted yes, and we can see that the total number of predicted yes can be given by this column, the sum of this column, and it is nothing but 100, and true positive is nothing but where is true positive? Okay, this is 100, so true positive is 100 and predicted total predicted yes is 110, so it will be 100 divided by 110, and it will come nearby I guess 0.64. Okay, now we know about recall and precision. So how to calculate the accuracy? Accuracy is basically simple, and it is not very much difficult. So the formula for accuracy is true positive plus true negative. So all the values that has been correctly classified or correctly predicted will come in the numerator, and then we'll divide it by the total. Okay, and the total number of records basically, and total number of records were 165. Okay, so 165. So total means you need to take the sum of this block, and this block, and this block, and this block. It will be the total, and it will come to be 165. So the true positive and true negative will be 100 plus 50, that is 150 divided by 165, and that will be equals to, I guess that will be equals to 0.91, I think. Yeah, 0.91. Okay, 0.91. Okay, so this is accuracy. Now there is one important metric that we should be knowing in at the time of classification. It is very much treated as a factor that control recall and bias. Okay, and that is Fbetascore. Okay, Fbetascore. So remember that when we take beta is equals to 1, then this thing is known as F1 score. Okay, F1 score, and you guys must have heard this many times. Okay, so Fbetascore is nothing but Fbetascore is equals to, let me write it down, Fbetascore is equals to 1 plus beta square, okay, multiplied by your precision, and then multiply it again by recall, then divide it by beta square, multiplied by precision plus recall. Okay, so these things are pretty straightforward. I think you got it. And when we talk about error rate is actually, you know it already. Error rate is given by 1 minus accuracy. So whatever the value that we get by calculating accuracy. So let's take a look again on the formula, so that we don't skip anything. Okay, and yeah, I said that I'll be talking about the confusion matrix for multi-class classification, but yeah, maybe it will be covered in the next video, because I know that it is itself getting bigger. Okay, so for recall we have this formula: recall is equals to true positive divided by actual yes. Okay, precision is equals to true positive divided by predicted yes. Okay, accuracy is equals to true positive plus for true negative divided by total number of, like, whatever the sum of the blocks that we have in our confusion matrix. Okay, then the most important thing that you should always remember is f beta score. Okay, so the formula for f beta score will be 1 plus beta, and 1 plus beta square multiplied by precision multiplied by recall divided by the beta square into precision plus recall. Okay, so this is here, this is it. And this beta, whenever we take beta is equals to 1, we give preference to both recall and precision. But we can basically shift the load or shift the weightage of precision and recall by just altering the beta, and it is very useful when we want to reduce the type 2 error. Okay, so these things are there. I will talk about the type 2 and type 1 error, and what are the significance level, how the power analysis is done to improve the reliability of a model. So keep watching this channel and subscribe to it. If you liked a little bit, like you got benefited by the explanation, then please press the like button. Comment whatever you need that I should be adding in these videos. If you want something that I should be covering, just comment down. Okay, keep watching. Bye.